Good morning, my YouTube viewers. In this video, what I'm going to talk about is debugging Python code. And Python has an inbuilt debugger module, which I'm going to discuss. So I've got two small programs that I'm going to go over that have the debugger code. So the first thing you have to import is PDB, and I think that stands for Python debugger. So, and then it has N equals next line, C equals continuous execution, L equals list sort code, Q equals quit debugger, and S equals step. So the first thing we'll do is we'll cover the factorial. So we'll press run module. So it says enter an integer you would like a factorial for. So what we're going to do is we're going to say 3, make it really small. And then so it says PD set trace. So we'll do S for step. Says if n is less than 0. And then S for step again. Result equals 1. Do S for step again. For I in range, 1, n plus 1. Do S again. Result equals result times I. Do S again. For I in range, 1 to n plus 1. Do S again. Result equals result plus I. Do S again. For I in range, 1 to n plus 1. Do S again. Result equals result plus I. Try it one more time. S again. And then S again. And then it says return result. So it's made it through the function. It's made it through the function and the for loop. You do S again. It says return result. You do S again. And it says def write self S program file window apps. And try this again. Do S again. If self close, do S again. And then it says error. So what we're going to do is we're going to do Q for quit. And it says print factorial num is a factor, and then it's quit. So that's basically how you use the decoder the debugger. And so basically what the S does is the S allows you to go through each step. So in this function, it went through for I in range 1 to n plus 1, result equals result plus I, and then return I. And so, and then it has the main. It says def main, num equals enter an integer you would like the factorial for. And then it says print factorial of number is factorial. And it says if name equals main. And it says main, so you've got your main. So that's one way you can use the debugger. But what we're going to do is we're going to run it again. We're going to run it again. We're going to make it smaller this time. 2 times 1 is 2. So it says set trace. So you can do L. And what that will do is that will list the code. So you can see the code if you want to see the code. It says we've done N, and it says C for continuous. So it says N for next line. Let's try N for next line. n, next line. If n is less than 0, let's write n, next line. Result equals 1, n, next line. For I in range I, n plus 1, n, next line. Result equals result times 1, n is next line. For I in range 1, n plus 1, n, next line. Result equals result times I, n, next line. For I in range 1, n plus 1, n, next line. Return result, n, next line. And now it just says return result, n, next line. It says def right self, n, next line. Program says if self.closed, n, next line. Give you some more things. It says self errors, n, next line. Return self writer, n, next line. Return self write. Try one more time, n, next line. And then we do Q for quit. So it's allowed you to quit. And then what the debugger does is the debugger can take you down line by line of the code so you can see where you went wrong. So we've done N, next line. One thing is C is, and we've done L, source code, and we've done Q, quit debugger, and we've done S, step. So let's try C for continuous execution. So we run the module again. So we'll say 5. And then we'll type C for continuous execution. Factorial of 5 is 120. So that was the factorial program. So now we have another smaller program called calculate price with debugger, and that's import PDB, and I think that's Python debugger. So you run the module. Enter price. I'm going to say 100. And then it says PDB. So we can do S for step. It says return price plus tax. And tax is 0.2, so tax is 20%. And so return price plus tax is the actual function. So we do S to step it. And it says return price plus tax. And then it says write self S, self closed. So that's finished with that one, but we can do L for list code. So that actually gives you the code, but you got the code already. And then we can do C for continuous, and then C is 120 because 100 plus 20 equals 120. And let's see what we've done. We've done next line. We've done step, I think we have. So let's run it again and try next line. It says enter price. We'll say 200, and that'll give you an outcome of 240. So we do N for next line, return price plus tax. N, next line, return price plus tax. N, next line, and then it just says def right self S. And we've done N, next line. It does the same thing. So you can do a list. So that'll give you the code. Def writable self, return true. Def write self S, if self dot close, raise value error, write to close file. So that's not very good, is it? So we checked the code. So we can type C for continuous execution, and that'll be 240. So that's a quick way that you can use Python's inbuilt debugger. I mean, me personally, quite often I use Google Colab. And Google Colab, if there's a problem in Google Colab, then it has a pretty good debugger. And now Google Colab has Gemini attached to it. And because it's got Gemini attached to it, not only if you have an error in the code, not only will it tell you that you have an error in the code, it will also give you a suggestion on how to correct the code. And I have used that before because sometimes, if I have problems thinking up programs and things like that. So sometimes I might use some old code. And the thing about using the old code is, as Python and Pandas and NumPy are supported, then the code might change, and then some code becomes deprecated. And so you might have a piece of code that maybe worked fine 5 years ago, but because Python or Pandas or NumPy or Matplotlib have been revised, that code is no longer good. And then so the thing about Google Colab, and especially that it's got Gemini attached to it, it will give you a recommendation for how to correct the code. And that is just how much AI has advanced. Because we didn't get large language models until I think 22 or 23. And I was programming in Python in 2020. And I think debugging has really advanced since we got large language models. But we do have this Python debugger, and you can use the Python debugger if you want to. And I just thought I would show you how to do it. And even with the Python idle, if you make a mistake in a Python idle, it will actually tell you that you've made a mistake. So let me just say, I'm just going to make a change just to let you see how the Python idle, instead of price item, I'm going to say price, and then I'm going to save it, and then I'm going to run it, and then I'm going to say 100, and then it gives you an error automatically. It says print, calculate price, tax item, and it says name price is not defined. Did you mean print? So we go back to change it back to price item, and you save it, and you run it. So we're going to say 50, and then we'll say C is 60. So even the idle has a pretty good debugger. So there's 3 ways that you can debug your code easily. You can debug your code using the debugger. I just wanted to show you how to use that. And then, but just on the idle, I've just given you an example of idle, how I've put in a mistake. And when I put in the mistake, it tells you what the mistake is on the idle. And you get the same debugging operation on Google Colab, if not better. So I've given you 3 ways that you can debug your code. One is with Python's PDB inbuilt module. Another is with idle. It has a debugger in it. It'll just go into error, and it'll tell you what the error is, and you have to fix the error. And 2 is Google Colab. I'm not going to call up Google Colab because I have called up Google Colab in the past. So that's it for this video. I'm going to go ahead and conclude this video, In the next video, I'll be talking about some more Python topics. So thank you for watching.